Okay, so what we're going to do is look at this triangle problem. You notice that we're given two sides and an angle, which is your SSA case, which means that there is a lot of different possibilities here. We could end up with no triangle, one triangle, or possibly two. So what we're going to do is see how this plays out and what kinds of things we have to watch out for when we're solving a problem with the law of sines. So it appears that we should use law of sines because we are given a side and an angle opposite that. Remember that that's one of the ratios that's needed. So I'm going to use the portion b over sine b, and since side c is also given, I'm going to do c over sine c. So that means that we're going to have 27 over sine 32 equals 40 over sine of c. So cross multiplying, 27 sine c equals 40 sine 32 degrees. So that means sine c is equal to 40 sine 32 degrees over 27. And I'm just going to inverse sine that whole thing so we don't lose accuracy. And what we get out of that is that angle C is equal to 51.7 degrees. Now, that looks like a perfectly fine answer, and I'm actually going to put that up here. Well, I'm not going to put it up here yet, but what we do have to watch out for is that remember that there's two possibilities for a triangle angle if we're trying to solve for sine. What I'm trying to say is, if I get 51.7 degrees, there is another solution that could work, because we just want sine of c to be that number. So if I have 51.7 degrees, remember that that's first quadrant, there's another solution in the second quadrant that has the same reference angle of 51.7 degrees. So we have to figure out what that is, and that angle is 180 minus 51.7, which is 128.3. Now, that's kind of funny because if I come up here, I look at the given angle 32, the second angle could very well be 128.3 because the sum is less than 180. So this case is going to give us two triangles. So what I'm going to do is I'm actually going to make another listing here for all of these sides here. There we go. All right. So here's triangle 2. I'm going to mark that here. And this is triangle 1. So now I'm ready with this information. So the original C was 51.7, so I'm going to put that one here. And the other C is 128.3 degrees. Okay, so what that means is we have two different possible values for angle A. Now remember, the sum of the three angles has to be 180. So 51.7 plus 32 is 83.7. So that means that this is 96.3 degrees. And for the other one, 32 and 128.3 is 160.3, which leaves us with 19.7 degrees. So now we are two ratios away from finding each triangle, and both of them involve having to find A. So I'm just going to label these triangle 1. I'm going to do try 1 here. All right. And I'm going to use, well, okay, just to keep things simple, I'm going to use the given ratio, or the given angle versus side there. So I'm going to say 27 over sine 32 degrees is equal to, and I'm going to have A over sine 96.3 degrees. And that means A is equal to the sine of 96.3 degrees times 27 over sine 32 degrees. And there A should be 50.6. Whoop, but not degrees. 50.6 should be the length of the side. Okay, and that does make sense for us because it is the longest side because it is opposite the longest or the largest angle. So that's going to be 50.6. And now we'll come over to triangle number 2, trying to keep everything in view here. So try 2. Now again, I'm going to use the 27 over sine 32. So that was the given ratio. The numbers are nicer. And I'm going to have A over sine of 19.7. And that tells us that A is equal to the sine of 19.7 degrees times that 27 over sine 32 degrees. And that should give us 17.2. So there we have our two possible triangles. There are the lengths and the angles of the two possible triangles from that given information.